Good afternoon, everyone. My name is Justin Johnson. Today I'll be presenting the scenario for patient travel support, which is a medical travel subsidizer operating with APAC, EMEA, and AMER across 10 different offices per each different region. The objectives are to develop a unified, scalable, and load balanced system that is able to replace the regional databases that have currently been developed across these different regions. And the risk identified is that there's going to be large data volumes that are projected in 5 years, including 38 million patients. We're going to be mitigating that through skinny tables and indexes for the operational master data. And then for any process-oriented data, those will be archived in cold storage after they're completed for the compliance with the retention policies. We will also mitigate the health insurance latency, given the fact that it's a 15-minute potential, 15-second rather, potential return. We'll decouple the integration via an ESB, and then we'll optimize for reads through the pre-preparation of data prior to the request. And then we're going to mitigate the compliance with PHI and PII data by leveraging Shield for the private encryption using private keys that are stored separate from Salesforce. And the assumption is made is that Salesforce will act as a system of record for patient data, as well as applications, assessments, treatments, and medical history. The insurance checker will be available for coverage and consumption. The identity providers will be Facebook for the external authentication, and then Active Directory for internal via Okta. Okay. Moving on now to the actors. We will start with the external users, which include the patients and the medical practitioners. Patients receive customer community license for the access to their own records. They'll be applying for support. Medical practitioners will be receiving partner community license for access to account teams. They'll be members of account teams for visibility. Managers and assessors will be receiving Service Cloud license as well as digital engagement for live chat and also access to cases. The role hierarchy will cascade from managers to assessors, and the record visibility will roll up from assessors to managers. Moving on now to the system landscape. We implement the solution using a single org to unify the data processing collaboration. I didn't see a need given data residency for implementing multi-org model here. We'll be leveraging multi-language for the multiple languages that will need to be supported for this global organization, and multi-currency for the patient travel support costs. The core cloud solution, the single org, will have digital engagement installed for the live chat. Locate will be installed for the geolocation and the address validation. Einstein bots will be enabled for the routing of live chats to bots and to save service agent chime. And then Shield will be enabled for the private encryption. Internal users will authenticate via SAML, backed by Okta, which is also backed by an Active Directory that is routed. That is per region. Okta will be responsible for routing the SAML request to those different, or the authentication to those different regions. The external users will authenticate using OIDC via auth provider that is returning an ID token that is validated by the auth provider, and then authenticating those patients directly. They can also authenticate directly with the username and password as well. Those will be using the Salesforce native credentials. The solution takes an API-led approach to integration. It's going to consist of using reusable APIs via an ESB that is also protected by a job-based trust model that integrates as well with a health insurance checker, which during peak times can often take up to 15 seconds to return results. So we'll be decoupling that, of course, to absorb the spikes during the peak times. And then the ETL will be leveraged for the migration from the different regional databases into Salesforce. We begin the process with the patient accessing the portal. They'll do so using OIDC that is based on the auth providers that is set up for Facebook. Facebook returns an ID token that the auth provider then validates, and then they're set up via registration handler within Salesforce as a user. They can also self-register with username and password as well. Both cases are created, their user is created using a registration handler, and then they will be able to authenticate using that user that's set up. The registration handler creates a person account for that patient, and then that directs them to a login screen flow that they will use to update their name, email, date of birth, address, language preference, and an insurance as well. There's a requirement here to pre-populate the personal data with attributes that are returned by the health insurance checker. This will be given the health insurance checker has a 15-minute like 15-second latency risk. We'll use the screen flow intelligently to, with the screen flow, screen one will be a confirmation for that patient to confirm that they are truthful in their responses within the screen flow, which will give enough time for the screen flow to return the pre-populated data from the health insurance checker using request and reply via the ESB from the health insurance checker. So we'll, at the point in time when the screen flow is launched, already be doing the request to the health insurance checker while they review this confirmation of accuracy that is going to be a single confirmation page. They will then confirm the pre-populated data. That will be the second screen, and that will also initiate the validation of the physical address that is inputted. This will be done via the locate installed package. That will then output the validity of the address, true or false, and then also return the geolocation that is stored on the patient record. The patient cannot apply for the subsidy until the onboarding process is completed, which is determined by a flag on the person account. And that flag is flagged once the screen flow is completed. The patient, once the screen flow is completed and the flag has been marked as true, then there will be a registered flow that will send an email to the patient with a Visualforce email template that is translated in multi-language via translation workbench and custom labels as well. The patient will be able to, once they've authenticated, be able to view the different 500 different treatment types in the iObject model. These are different products. These products will be available for the patient to select as they go navigate through a screen flow. That screen flow will initially create an order. The order represents the actual application. That order, when it's created, is assigned to the assessor queue, which is that regional queue for the different for the internal users. The order items are the different treatment types that they're applying for. And then medical information is stored in a separate object for security purposes. They will then be able to verify the medical information and associate the medical information with each individual application as they are navigating through the application and navigating the application and submitting it as well. So once they verified the medical information, that will then look up to the order will look up to that medical information record. And then the system itself will confirm that the patient has health insurance that already covers travel costs. If so, they won't be able to apply for coverage, or they won't be able to apply for subsidies. This will be preloaded on the account record itself from that initial step where they've submitted their initial information. But given the fact that they can continuously change insurance over time, we will make sure that there's a record trigger flow on the account insurance number field that will update their current coverage field. If it is false, then we will enable orders. We'll enable them to apply for applications. in that case. So we will continuously update their coverage, whether or not they're covered, so that if they were to lose coverage, they can then update that and then make applications later on. This is also to optimize for read, given the latency constraint with the insurance, health insurance checker, so that we're not querying at a point in time. We are querying at the point when they've updated the insurance, rather. When the subsidy application is created, the medical practitioner that is registered for the treatment type is automatically allocated via the case object. So when the order is submitted, there will be the creation of a case that is assigned to the assessor queue. That case is marked as status new. That triggers then an approval record triggered flow that updates the case as pending approval, and then most importantly updates the case's medical practitioner field with an account lookup. That is with the MP lookup rather. That will assign the MP based on the combination of the medical practitioners that are assigned to that treatment, as well as the medical practitioner's geolocation that is stored on the medical practitioner's record itself. So once that initial treatment, the appropriate medical practitioner is determined, they're assigned to that lookup on the case, and then that also follows a record trigger approval flow that creates the process instance record that is tracking the submitted case, and then the process instance work item that is associated with the pending approval medical practitioner. If the medical practitioner, once the medical practitioner is assigned that process instance work item, that case status is updated to pending approval. That then triggers a record trigger flow that sends a notification to the medical practitioner. That is then triggering the first step, where if they approve it, that will create the, if they approve and they are okay with the application, that they, within 3 days, they're amenable to accepting it, that will create medical history share records that are associated with medical information that they have access to, and then update the case status as approved. If they reject, that will then repeat the same approval record triggered flow as pending approval, and then it will determine what is the next medical practitioner or next best medical practitioner based on the geolocation and the appropriate MP treatment based on the mapping of the product to medical practitioners. If they don't respond within 3 days, then the same thing occurs as as a rejection, where it follows the same process as well. This will be done based on the record trigger. Based on a scheduled flow. Digital engagement will be installed within the org for live chat, and then we will also enable. Make sure this is clear. We'll have Einstein bot that will be the first line of defense for deflecting support requests for common questions, and then the second line will be the live chat via the support agents that will be the PTSF assessors that will be able to chat with the medical and patients, MPs and patients via the live chat feature. The medical practitioner will be able to assess the application on the case record itself. The current process is very flat file heavy with completed PDFs that are sent to the assessors via email. So we're going to replace that with a digitized process on the case object. And then there will be the ability for the cases to be escalated to the managers based on the number of days it's currently sitting with the medical practitioner. If it is sitting with the MP for 15 days, then we'll update the status of the case to escalated and then assign the owner as that manager that is within that region. If the MP needs additional specialists to assess the patient, then they will create an additional child case specialist record that has a hierarchical lookup to a user, which is the MP. That will simultaneously create an account team member associated with the patient that will give them access read-only to the case itself. Once the case is approved, they will then update the case as the status is approved, and that will then, based on the quick action of the approval, that will then update the case MP field as null, so they lose access via the sharing sets to the case, and then also deletes the medical information share records that are associated with the MPs as well. The assessor will then be responsible, since they are then going to be the only ones accessing it via this assessor queue. And they will be able to then, based on an LWC rendering of the distance between the geolocations between the MP and the patient, they will be able to determine the appropriate subsidy based on the distance between the two. And this will be based on metadata records that are stored behind the scenes in setup objects. Moving on now to data requirements, the accounts, there's a large data volume here of accounts that require retention of 38 million, what I'm projecting 38 million accounts for patients in 5 years. Since this is master data, we will need to store them on platform, but we'll mitigate the storage of such large data volumes on platform through the skinny tables and custom indexes to mitigate and protect the platform performance. And then we'll also have a long tail archival policies to tier the data if in case there is, if there are patients that are inactive for extended periods of time as well. Additionally, there are process objects involved that include large data volumes that amount to 13 million subsidies or cases in my object model, and 13 million in 5 years. So in order to maintain the transactional performance, we will retain the 13 million. And in order to also retain the, while retaining the 13 million on the platform, we will set up retention policies that will move the subsidies to big objects post completion, so that we aren't storing non-operational records as hot records on the platform. And so we'll assume that this is in compliance given the fact that it's in cold storage on platform. The reason why I chose not to use external objects here is since it is PHI data, it's more secure on platform. And also, since we have enabled Shield, we also have encryption at rest with private keys that are ours. The existing patients and subsidy applications need to be migrated in the new system. One thing that we need to, of course, do is protect the system performance with the large data volumes. And to do so, we shouldn't be storing non-operational data on the platform, so we'll be storing those in big objects, and then that will I'm assuming that will comply with the retention policy that's described here. And then the existing subsidy applications that are completed in the current system will need to be migrated into the new system to comply with the 5 years retention policy. So what I'm recommending is that we run a paralleled run for 1 month for the remaining operational records from the legacy systems. And then we tier the current system completed records so that we are, as soon as they are completed, we are migrating them into Salesforce into the big object cold storage. So there's going to be a parallel run but it's going to be a short duration and it's going to be progressive over time and only for 1 month, so that we are in compliance with the 5-year retention policy. Okay. And then finally, on visibility and accessibility, we have medical MPs that need to be able to view all assessments for patients related to the subsidy application. This will be enabled via that account team member, via the creation of account team members that grant read-only access to cases that are related to accounts. This will be facilitated by the case specialist object, as well as via the assignment of an MP to the case itself. Only the medical practitioners should be able to see the medical information. This will be can only see the medical, the patient name, phone, and email, as well as the patient description. So this will be enabled via FLS on the patient on the patient object, and then the MP will have only access to those certain fields. And then the MPs will only be able to MPs will be the only actors to see the medical history besides the patients. The MPs will gain access to the medical information object via the custom share records that are created via the case specialist object. And there will be a scheduled flow to delete the custom share records that are sharing the medical information with the MPs when the cases are closed. So there will be a progressive deletion as soon as the cases are closed of the custom share records. And then of course, the internal users won't have access, so they won't have access because their permissions won't grant the OLS access themselves. And that's it. Thank you very much.